Good afternoon, everyone, and welcome to today's webinar. We're very pleased to welcome Gary Pharo of Sundstrom today, who has kindly agreed to deliver this session. And I will shortly hand over to him, but before I do, I just wanted to mention a few things. So firstly, I'd like to introduce myself. I am Dimple Chauhan, and I will be taking care of the technical aspects of these sessions. Any problems, and I shall try to assist as best I can. So on your screen, most likely located at the top left-hand side, you will notice a small bar with some written options on them, which are chat and Q&A. If you have any technical issues or audio problems and need to message me at any point, please use the chat option. If you have any specific questions for Gary relating to the content of the session, please use the Q&A option and ask your questions here. I will run through all of these with Gary after the presentation has finished, and will aim to tackle as many of these as possible. And if we run out of time and there are still questions remaining, we will look at these after the webinar and aim to post some written answers online at a later date. So, with all that said, I shall now hand you over to Gary and hope you all enjoy the session.
Good afternoon, everybody. Thank you for joining us for this, what will be a two-part guide to respiratory protection in construction. I'm sure most of you are familiar with Sundstrom. For those of you who may not be so familiar, we're a Swedish company who have spent the last 92 years protecting people from hazardous products in the air. Our goal is to ensure that people remain protected, and my goal over the course of the next two sessions that we'll be doing. So part one today in September, part two on the 21st of November. We'll talk a little bit more about that at the end of this presentation. But part one today, we're going to cover some of the common challenges around respiratory protection in construction. We'll look at some cold hard facts. We'll run through hierarchy of controls. It's important to cover that. And then we'll look at some legislation and how you kind of implement a respiratory protective program. I'm going to touch on some issues around exposure levels and protection factors, because they're things that quite often people find challenging. And we'll certainly talk about facial hair, which I'm sure is something that you all have as one of your key things to look at. Before we get into this, I think it's important to look at human nature, and these two images really, to me, sum up more about the human nature than many words can, particularly in the construction industry, where whether we like it or not, it's still very much male orientated, and where we are men, and we like a bit of man glitter. And unfortunately, the kind of stubborn aspect and the fact that we always think we know best means that we don't necessarily protect our health as well as we can. And we can change that, certainly, with a good level of training and education. When I visit construction sites, indeed pretty much any site, the most common issues and challenges that people have to overcome with RPE compliance are, as are coming up on your screen now. So some of these could be genuine, with people being unable to breathe in a mask or feeling claustrophobic, and certainly we'll talk about that later. Some of them may be able to be addressed by training and by education. Some of them you may need to work through your own internal disciplinary processes. But on the whole, we can make a difference. For me, the biggest challenge is this fantastic thing of size. Now, size really does matter. When it comes to respiratory protection, it's the smaller size particles which are problematic. So if we look at this schematic of different sizes of particles, these are based on microns, which is 1,000th of a millimeter. The visibility limit for most people with the naked eye is 17 microns. What that means is that everything to the left of that line is invisible to the naked eye. And of course, like the monster under the bed, if we can't see it, it can't hurt us. But it is there. So getting people to recognize that just because they can't see a hazard, it doesn't necessarily mean it's not there, is one of the key aspects. And when we then look at those particle sizes and how they affect the human's respiratory system, this I think is equally key when it comes to educating people as to how respiratory diseases occur. So particle sizes come in three groups. Above 100 microns, a particle will be affected by gravity and drop to the floor. At around about 100 microns, you'll inhale it, and at 10 microns, it will get as far as your throat. But your body's got a fantastic self-defense mechanism in terms of hair and mucus, and that will capture a large percentage, most of the particles that are above 10 microns. And then you'll either blow your nose, cough, or sneeze, and your body gets rid of those damaging aspects. It's the particles that are below 10 microns that are damaging. Of course, you know, as we've just seen, you can only see down to 17 microns with a naked eye. So you're not able to see the things that are really causing you a problem. And at 4 microns, they get really deep into your lungs, down into your alveoli, which is where the act of respiration takes place. So when you breathe in, oxygen goes into your blood, is fed around your system, and then feeds muscles and organs as is required. And then, of course, as the blood comes back around again, it picks up CO2, and when you breathe out, you exhale CO2. Now, all these alveoli inside us are about 75 to 100 square meters. If you took them out and flattened them out, that would be the surface area. That's the typical surface area of a 3-bedroom house, not the size of a 3-bedroom house, obviously, but the floor plan, the size of the floor plan of a 3-bedroom house. And this, combined with sizes, is one of the major problems, one of the major reasons why we find we have respiratory disease. And it's because, quite simply, we don't recognize that we're very, very slowly reducing our ability to breathe. We've got a massive over-engineering in our bodies, and that's probably because 10,000 years ago we were either chasing after a woolly mammoth trying to throw spears at it, or running away from a saber-toothed tiger. So our bodies needed a lot more oxygen to go about our daily tasks. These days we tend to lead a more sedentary lifestyle, and so we don't tend to notice that we're losing our ability to respire until it gets to the point where, sadly and unfortunately, it's normally too late. So to look at some cold hard facts, and specifically some facts if we look at these around construction. Number one is the percentage of work-related deaths attributed to poor safety, and 99 is the percentage of work-related deaths attributed to ill health. So the vast majority of people who sadly will succumb to a work-related death, it's going to be around ill health. There was something like 35, I think, construction workers sadly died in 2014 to 2015 from fatal injuries. But over the same period of time, around about 9,000 either contracted a new cancer or sadly died from cancer. There's a huge percentage. And if you're in the construction industry, you're 100 times more likely to die from an occupational disease than a workplace accident. Now, thankfully, times are changing. The focus, whilst it needs to remain obviously on safety, we mustn't get complacent on that, but the focus is shifting more to health, more to health-related issues, and people are spending more time and effort in looking at how we can deal with them. That having been said, there are an estimated 18,000 new cases of breathing and lung problems, according to the 2017 Labour Force Survey, which is the most recent one. That's up 4,000 from the 2012 survey. So in the last 5 years, it's gone up by 4,000. And within that, about 40% of those are things that could directly be attributed to construction. So whether that's dust from stones and cement, airborne materials from spray painting, such as isocyanate, or airborne materials from welding and soldering, all of these things will contribute to potential respiratory diseases. If we take some specifics, I'm believe that you've been doing quite a lot of work on silica and asbestos already, but silicosis will by the latest numbers, kill around 800 people this year. Asbestosis around 600. And those two diseases are part of a group of diseases called pneumoconiosis diseases, similar to farmer's lung or coal miner's lung. And they're diseases that do affect the alveoli and reduce your capacity to process oxygen in and CO2 out. Mesothelioma is the cancer from asbestos, and will kill around 2,500 people this year. That will continue for some time at that level. The expectation is that by about 2020, it will start to dip, and by about 2030, it will be down to, dare I say, just 2,000 people. So it's still a serious issue. And it doesn't matter what area of construction you're working in, the mesothelioma and asbestos is likely to affect you. Some frightening facts on it. 1 in 5 work-related deaths are caused by mesothelioma. The thing that gets me more than anything else, I think, is the fact that there'll be 20 tradespeople. This week, 20 tradespeople will sadly die from mesothelioma. And these aren't people that are ripping out asbestos for a living. These are jobbing, what I would call white van man. You know, joiners, electricians, plumbers. The joiners may be where they're cutting through asbestos sheets in the past. Electricians and plumbers fairly typically where they're removing lagging or Artex ceilings where they're pulling wires and pipes through. So it affects every part of what we're doing at the moment in the construction industry. Other hazards that you're likely to come across, and very common ones, include isocyanate in paint, so anything in a 2-pack paint, wood dust, mold, metal fume, metal dusts. And these things are things that could trigger diseases such as asthma, which is the most common lung disease in the UK, affecting some 12% of the population, so that's around 8 million people, and sadly killing 1,200 a year. And COPD, which is the behind lung cancer, kills more people in the UK, around 30,000 people. Around 15%, so about 4,000 of those are work-related, and COPD covers things like emphysema, chronic bronchitis, and will be where people have been sensitized to a product over a period of time. So pretty dark, right? But there is a positive outlook on this because we can change it. The good news is we can change it, and we can prevent most of these deaths by recognizing the hazards, by evaluating the risks, and by controlling exposures. These are things that we should be doing as part of our everyday life when we are performing our risk assessments and looking at what we need to do. But the education, so not only the health and safety manager is recognising the hazard, but the education of the individual so they understand it is really key here. Of course, once you start writing your risk assessment, we need to be going into the hierarchy of controls. Which I'm sure you're all familiar with, but very key, you should only be using RPE after you've taken all other reasonably practicable measures to prevent or control exposure. So ideally, if you do that, then myself and people like me are out of a job. And I'd be quite happy if that was the case, if I'm really honest, because that would mean that people aren't being exposed to hazardous substances. But the reality is that we don't get rid of them, or we can't get rid of them in most instances without going to PPE or RPE in this instance. So we need to go through that hierarchy of control. Eric Pickles, as I think of it. So starting by eliminating, then replacing, isolating, changing the way that people work, and then protecting the worker. So to look at those very briefly, from an elimination point of view, we could do something as simple as just not mix concrete on site and bring it in ready mixed. If it's wet, we won't get any plumes of smoke that are coming up from it. We can replace it. So we can take a paint that contains isocyanate and replace it with a paint that has no isocyanate in. Other brands are available, of course. We can isolate people from the hazard, and certainly in the construction industry, the 3 most common ways that we do that would be through water suppression. And you need to have enough water on here to make sure this is working. So not just a little dabble, the water needs to be on all the time. On-tool extraction, even in your local DIY stores, The tools are now available that will hook into your vacuum at home. And of course, there are form of local exhaust ventilation, or you can go for something that's a bit more robust in terms of local exhaust ventilation, whether that's inbuilt or a mobile product. There's some really good ones on the marketplace now. And we will look at some of those in the second part of this seminar in November. The next thing you can look at doing is changing the way that people work. So that could be to reduce the time that they're exposed to the hazard. Or alternatively, we can reduce the number of people that are exposed to the hazard, or rotate people's tasks. And then finally, we get to protection. If we can't protect people up until that point, we then need to form a respiratory protective program and provide people with respiratory protective equipment. When I talk through some of the legislation aspects that I'm going to talk through in a moment, these are the references for those. I'm not going to go into them into great detail, other than to say that if you haven't read the bottom three, so 529/2005, which is your guide for implementing a respiratory program, HSG 53, which is the practical guide from HSE for respiratory products, and the OC 28228, which is the guide for fit testing. If you haven't read those three or haven't seen them, I would highly recommend that you download them and do so. Some very valuable information in there. But in terms of what legislation actually requires, well, if you're going to be using RPE as a control measure, our old friends adequate and suitable come out. And of course, if you're using it, you must reduce that exposure to as low as is reasonably practicable, and in any case to an acceptable level, so below the workplace exposure limit. And again, as I said, we'll touch on that a little bit later on. As far as construction is concerned, HSE guidance looks at RPE and suggests that you should be using RPE with an assigned protection factor at least of 20. Again, we'll talk about assigned protection factors in a bit. It needs to be suitable. You need to be aware that, you know, if you're wearing a disposable mask or a half mask, they can be uncomfortable if you're wearing for a long period of time. The RPE needs to be compatible with other products, it needs to be worn correctly, and you need to be face fit tested, and anyone using a tight fitting mask needs to be clean shaven. So from an employer's point of view, your obligations under implementing a respiratory protective program are to have the expertise, obviously, to create and pursue that, to provide equipment that's suitable, to provide training in fit, use and maintenance, to monitor compliance, and then to produce documentation as is required. The employee also has some obligations, and they are to comply with the program, to report any problems, and then to use the equipment in the manner in which they've been told to, or shown to, or trained to, including putting it on properly, maintaining it, storing it correctly, etc. So the employee's obligations and the employer's obligations really sit down and form from what is an RPE program, a respiratory protective equipment program. Now, to have an effective program, you need to follow a number of steps. You need to correctly select the RPE, you need to train for the use, you need to ensure correct use, including supervision and where necessary. You need to discipline if people aren't wearing it. You need to check to ensure that the RPE is working correctly, maintain it, keep records as required by law in most cases for 5 years, correctly store it and correctly dispose of it. Now, an RPE program is quite complex, and we don't have the time today to go into that, but a respiratory manufacturer, certainly we would, help you to go through that. Any good one will, and any good supplier will. But today what we're going to focus on primarily is correctly selecting the RPE, because it's really important we get that bit right. If we don't get that bit right, then we're in trouble further on down the line. So to correctly select it, we're back to our two friends, Mr. Adequate and Mrs. Suitable. The product needs to be right for the hazard and reduce the exposure to a level that's going to protect the worker, and it also needs to be suitable in terms of being right for them, the task and the environment. to ensure that RPE is suitable and adequate, it should be right for the hazard, right for the task, and right for the person. And if you take nothing else away from today, then just take those three phrases, because if you get those three things right, fairly typically, what you're going to ensure is that you're giving someone something that is suitable and adequate. So those are the things that we're going to focus on for today. So in terms of hazards, there are two types of contaminant and three risk areas. I'm not going to talk about confined space today, as you can probably appreciate. That could be a session all in itself, or maybe a week session. So we're going to take lack of oxygen away, although we will touch on it slightly over the course of the next two sessions. And we're going to focus on the two most common contaminants that you're going to find particularly in construction, which is gases and vapors and particles. So to define those, a gas is a substance that will fill any given container, whatever that is, a room, a hole in the ground. It has no fixed shape, no fixed volume. It will just keep going. A vapor tends to be formed from either the evaporation or the heating of a liquid or a solid, so things like solvent or paint vapors, or vapor off of fuel, diesel, petrol, etc. And they will need a specific type of filter. When you look at particles need a different filter to the gas filters, and particles come in many different forms. So they can be inorganic in the terms of wood, silica, or asbestos, for example. Organic, bacteria, molds, or fungal spores, mites, and indeed liquid in their format, so in the form of mists, sprays, and fumes. So in the construction industry, whether you're knocking down, building, or refurbishing, you're likely to come across most of these types of airborne hazards at some point. And they will need a particle filter, and filters we will talk about in the session in November. So once we've worked out what form that hazard's in, we then need to work out how much of that we can expose people to in the course of a typical day, and that's what's referred to as the workplace exposure limit. Whatever the product is, you will be able to find it in this wonderful document called EH40. A new edition has just recently been published, and it will give you the individual substance and the long-term and short-term exposure limits that you can be exposed to over the course of a day without it causing you any harm. The only thing I would say to this is obviously an average person, and I'm pretty sure if you sit down with 10 of your friends, whether your tipple is wine, beer, or a spirit, each of you will be able to drink more or less than the others. So sometimes you might need to play around with this in terms of people being a bit more sensitive to certain things. However, these are your legal requirements in terms of the exposure limits. And if we take acrolein as an example there, that's extremely low, and that's a typical product that's used to suppress weeds or for weed killing. You can also find this information on material safety data sheets. Now, I always find safety data sheets to be a bit challenging, because although some of them will have this information, most will have a limited amount of it. As an example, I've just Googled acrolein and picked up five different data sheets here from different providers. Now, each of them suggests that you use a different type of respirator or a different type of filter, which is a bit worrying really, because you've got everything there from an organic or from a vapor respirator, which could be pretty much anything, through to a disposable mask, a reusable half mask, self-contained breathing apparatus, and somebody very kindly has invented a filter called an AXBEK, which to the very best of my knowledge nobody makes. So once you know what your hazard is, and once you know what your workplace exposure limit is, if you're unsure, then please speak to a manufacturer or to one of the larger suppliers. They should be able to give you that information. People like ourselves have now got apps where you can go on and input your hazard and find out what filter you may need. but certainly all of the larger providers out there, ourselves, Scott, maybe someone like Alpha Solway or Moldex, if you're dealing with them, we'll all have technical helplines, and we can help you. So if you're unsure, then please pick up the phone or send in an email, and I'm sure that every manufacturer will be happy to help you. So once we know how much we can expose people to, we then need to work out what type of mask and what level of protection we need to give somebody, and that's the assigned protection factor. So you should always use this to determine what you need, and in simple terms, it represents the difference between the air inside the mask and outside the mask. So if you've got something with an assigned protection factor of 10, it means you're getting 10 times cleaner air inside the mask. Assigned protection factor of 20, it's 20 times cleaner inside the mask, etc. Very important to recognize that that's the level of protection that can realistically be expected to be achieved by 95% of adequately trained, supervised wearers using properly functioning and correctly fitted respirators. So just giving someone a mask is not good enough. They need to be shown how to use it. You need to make sure that it fits them for it to get that sort of level of protection that it's designed to do. And of course, in all instances, we need to make sure that it reduces the exposure as low as is reasonably practicable, and of course, below our old friend, the workplace exposure limit. So to calculate your assigned protection factors, it's quite a simple calculation. We need to know what the contaminant concentration is in the area where we're working, what the relevant workplace exposure limit, and if we divide the contaminant by the exposure limit, we then get the protection factor. So if the contaminant concentration is 200, the exposure limit is 10, that gives us a protection factor of 20. I've chosen those numbers because I'm not very good at maths, and it's very easy to do. But that gives you where you need to be. So that would be a minimum. Now that's going to reduce it down to the workplace exposure limit. So in an ideal world, in this situation, you choose something that has got a protection factor above 20, which will be 40 actually in this instance. You can reverse that calculation and look at a particular mask that you're using or respirator that you're using and work out what the highest concentration is that you can actually use that particular mask in, and that's just to multiply the workplace exposure limit by the assigned protection factor of the mask, and that will give you the maximum contaminant concentration. In this instance, it happens to be exactly the same. Every mask has its own assigned protection factor. So we will talk more about this in the second session in November. There's a couple of things I just wanted to quickly clarify. Disposable masks or reusable masks. So disposable FFP, that stands for filtering face piece. So that's your disposable type of mask. They come in 3 levels, 1, 2, and 3. Any particle filter also comes in 3 levels at the moment anyway, 1, 2, and 3. And they will give you respectively protection levels of 4, 10, and 20. Any half mask will give you the same level of protection legally. So with a particle filter in a half mask, it's still going to give you a protection factor of 20. That's the same as a P3 disposable mask. If you move up to a full face mask, that will give you twice the level of protection. And these are all tight-fitting masks that will require you to be face fit tested. The next step up, and what we're seeing more and more of within the construction industry, are powered respirators. A caution for you here, they aren't all the same. So in the same way as disposable mask, powered respirators have got 3 levels, 1, 2, and 3. If it's a hood, it's a TH, and if it's a mask, it's a TM. That stands for turbo hood and turbo mask. So for construction, we need to be very clear. You must have something that's got at least a level of TH2, because from an HSE's point of view, they're saying you need something with a protection factor of 20. There are a lot of TH1 level powered respirators out there. They may be suitable for certain tasks, but they're not suitable for the vast majority of tasks within the construction environment. So I would caution you on that, because I've seen plenty of businesses who unfortunately have spent a lot of money on them and then been told that they can't use them. The other types of breathing apparatus that you can use within respiratory is compressed airline or demand valve, so moving up to things like positive pressure, a fireman's outfit, or for that matter, something you might use in a confined space. Again, as I said, we'll talk more about this at the next session in November. But I think it's important to clarify where you sit in terms of protection factors, particularly with those top three, which are the most common ones that are used within the construction industry. So once we've got something that's right for the hazard, which we should have now, we now need to look at the task. We need to look at the things that you might need to consider around that. So that includes things like work rate, wear time, any sort of abnormal temperatures or humidity, lack of oxygen. If you're going to ask someone to wear a mask for 4 hours a day in a really hot environment and giving them a disposable mask, probably isn't the best thing to do. They'd be probably a lot more comfortable in a powered respirator. Then we need to look at the mask being right for the person, and we all come in different shapes and sizes. So things that we might need to consider here include whether the individual wears contact lenses or spectacles. So if you wear glasses, you can't wear a full face mask with your standard prescription glasses. A full face mask, let me be clear, is a tight-fitting face mask. A lot of people call a powered respirator with a hood or a helmet a full face mask. It's a terminology that's sometimes used. Technically, it's not right. So a full face mask is something that seals tightly to your face, and you can't have something with the spectacles with that because it will break the seal. Other things you might need to consider are facial hair, and we'll get onto that in a sec, or somebody that maybe has some piercings in their face outside the area of where the mask may be sealing. And any pre-existing health conditions. So it is quite feasible that people will find it difficult to breathe through a mask if they've got asthma or any pre-existing health condition. In that case, it's probably not the best idea to put them into something that's got no valve on that's going to make it really difficult for them to breathe. So all of these things we need to take into consideration. Facial hair. Now, we could spend days and weeks on this, and I'm sure you have, all of you individually. The reality, if you're clean shaven, a mask will give you a level of protection. It doesn't matter what that level is, but it will give you a level of protection based upon the fact that the mask is sealing to your face. If you have stubble in the area where the mask seals, and that's the key thing where the mask seals, you will lose 90% of the protection that mask provides you. You'll only get 10% of what you're expecting to achieve. So if that's a mask like a powered respirator with a tight-fitting face mask, very important, then that would be giving you potentially a protection factor of 40 if you're clean-shaven, but it's only down to 4 if you've got a beard. Stubble rather. It's even worse if you've got a beard because that knocks out 99% of the protection. Now these aren't figures that we've just plucked out of the air. We've tested at Sundstrom in Sweden pretty much every mask that's ever been made. We have the facilities there as every other manufacturer does, and we all do the same thing to look at what we're all up to. So with the exception of some of the cheap and nasty things that gets produced, we've tested every single one. These are the figures that we know are factual from the tests that we've done. What constitutes facial hair is something which is a question I often get asked. I have quite happily plagiarized this from the United States, from OSHA, because I think it's a fantastic little graphic. You can use it. Clearly shows where a half mask in this instance will be sealing to the face, and the different types of facial hair that you can have. I'm not a hipster, so I didn't realize there were quite so many. I thought it was just stubble and a beard. But I'm particularly keen to try out the villain down there at the bottom. But it does have some good guidelines there. So ensuring that if you've got a goatee, for example, second line down, second from the left, be careful that the chin hair doesn't cross the seal. The important thing is that facial hair does not interfere with the seal of the mask. If you have got people with facial hair, well, you have got some options. The first and the simplest is to remove them from the environment. But of course, that isn't always possible, or indeed for that matter, it isn't always realistic. The next thing you can do is introduce a clean shaven policy. That can be challenging, and it can be difficult to enforce as well, but at least it does establish a level playing field. And otherwise, your third option is to supply an alternative form of RPE that doesn't rely on a tight seal. So that is a powered respirator with what's called a loose-fitting hood, not a tight-fitting mask, but loose-fitting hood. Now, the right to have facial hair is often cited as a reason for not being clean-shaven at work, but there is no such thing really. You need to balance that with the Health and Safety at Work Act of '74, which says that employees are required to follow any training that they've received. They need to take care of their own health and safety, and they need to cooperate with the employer on health and safety. So there's a balance there. That having been said, I know many businesses will balance the cost of buying a powered respirator against the loss of a skilled employee who resists not being clean shaven. And certainly it could well cost you a lot more to replace that person than just to buy them the respirator. That's a decision for you to make. And it's also worth bearing in mind that if you correctly choose a powered respirator, then it will provide you with protection to head, face, eyes, in some cases the neck. It will protect, you know, depending upon the sort of hood that you might give somebody, protection from chemical ingress into the skin as well. So it removes any incompatibility with other PPE, and from a health and safety point of view, a health and safety manager's point of view, it will ensure that you've got compliance at a glance, so nice and easy to look at. If you're unsure of it, I've put this link on here. We're not going to click on it and watch it, but you can look at it afterwards. It's a fantastic link to an Australian site. It's about 2.5 minutes. It will clearly show you the difference between being clean shaven and having a beard and facial hair, and what effect that has on a mask. So we get on to face fit testing, and face fit testing is a requirement of your selection process. It's often cited that 50% of RPE doesn't offer the wearer the right level of protection. Well, some of that is because people are wearing it with stubble or with a beard, but primarily it's because the correct level of protection, or the level of protection that mask is designed to give you, it doesn't, quite simply, because you haven't been adequately trained, supervised, or face fit tested. So the British Safety Industry Federation has worked with the HSE, and you've got the Fit to Fit accreditation. Now, if you're going to go down the face fit testing route, it would be my advice to use someone that's Fit to Fit accredited. You can go onto their website and find people local to you or further away if you wish. There's also a lot of people in the construction industry that will go through the training course, the fit testing training course. This is not train the trainer. I think that's a bugbear for most people within the respiratory industry. It's train the tester. So this will allow you to train a number of people within your organisation to do face fit testing internally. It's important to realise that if you go through that training and then you don't face fit test anybody for a year, your competency is likely to be called into question. So if you're going to train people to do this, then it is important those people are doing it on a regular basis. But again, we would always recommend you using a Fit to Fit accredited company. As far as face fit testing is concerned, there are two methods. So the qualitative, which is the most common certainly in the construction industry, is suitable for any type of half mask, whether that's disposable or reusable, and is based upon a bitter or a sweet spray being sprayed into a hood. You perform a number of tests, and if you can't taste the spray, then the mask is deemed to fit you. More robust method is with a Porta count machine, which physically measures the number of particles inside and outside the mask, and will give you a fit factor. Both methods are considered as acceptable by the HSE in terms of face fit testing, and both of them use the same, roughly the same period of time, and certainly the same exercises that you will do. But at the end of it, you'll know if your mask is fitting you. I do want to spend a little time talking about fit checks, not too long, because this has been a bugbear within the industry for a while. You should do a fit check every time you put a mask on. It shows if you've got a reasonable fit, but it certainly isn't a replication of typical work. So to be really, really clear, it's not a face fit test, it's a fit check. Every manufacturer of masks has the ability to do this. Every type of mask has always been able to do this. This is not something new. If you use a disposable mask, the method for that would be to cover the mask up and exhale. Hopefully you'll find the mask bulges out and the air doesn't escape from the side. If it does, it's not fitting. You can also do a negative pressure check, which is to breathe in and the mask should suck into your face. Back around about 2005, a little company called 3M came out with a set of filters that you could push on to check whether the mask was fit. And certainly this is a method which has been pushed quite recently within the construction industry, but is far from a new technology. And many other manufacturers will just look at covering over the filters and breathing in. For ourselves, the typical way that we would do it, you would cover over the inhalation valve on the front of the mask, breathe in, and the mask should seal to your face. But it's not typical of what you do all day long, right? Because you don't walk around with your hand over your mask all day, breathing in. So it's not a face fit test. It's just to check that the mask is sealed to your face well each time you put it on. So if we go through all of those processes, we should ensure that our RPE is suitable and adequate. We should have checked that it's right for the hazard, that it's right for the task, and that it's right for the individual person. So we should find that we're being compliant. That takes us to where we are for today, hopefully covering off the common challenges, some facts and the legislation, types of hazards and face fit testing. I hope that you'll be able to join me on the 21st of November for the second part, where we'll talk a bit more detail about the different types of masks and filters. Some of the aspects of that fill up a respiratory protective program, including fitting and maintenance. We'll also talk a bit about counterfeit products, which are becoming problematic, and certainly things that are around in the future, so in terms of innovation, and some approaches from other countries. In between times, there are some fantastic resources out there. So whether that's the IOSH's No Time to Lose campaign, which is brilliant, a very recent campaign from the HSE, which is Go Home Healthy, fabulous campaign with some great videos, Construction Industry Partnership and the Clean Air from BSIF that have been around for a while, and the Breathe Freely campaign, which is again a superb resource with some fantastic information on there. Thank you for your time today. My contact details are at the bottom if you'd like to contact me directly. Happy to connect with you on LinkedIn, but now it's over to questions.
That's brilliant. Thank you, Gary, for your presentation. So now it's over to you. You've got the opportunity to post any questions you may have for Gary. But before I forward your questions, I'd like to launch a poll, as your feedback on our webinars is very vital. So I'm just going to do that now. Okay. So you'll see a poll just come up on your screen, and if you can please give us your feedback, that would be great. So while we're doing that, I've got a question for you, Gary. So I live across a field that until last year had a asbestos sign. During this year, they took off the sign and now they are working, digging and preparing the field for construction. And they are working without any control measures for the workers or the public. Is this right, and what can they do about it?
Well, okay. I think that's probably something that would be better if I take offline. I'd be very happy to put an answer back to that. But in simple terms, control of asbestos regulations would state that they would need to be complying with those. But it's far too detailed to go into, I think, in the time that we have. So thank you for your question. I'll happily come back to that later.
Okay, thank you. Do we have any more further questions? Now's your chance to post them to Gary. So we don't seem to have any further more. So I'd just like to end the session by thanking Gary and thanking you all for joining us for this webinar today. We will be sending out the presentation and the recording to the email address that you've registered with. There's no more further questions that are here. You also have Gary's details as well, so if you do want to contact him directly, he'll be happy to speak to you there. Right, so I'm going to wrap up the session. Thank you very much, Gary.
Thank you.
Thank you.